everyone, my name is Alima Balu and today we talk about the oscillation of an object. We'll talk about the introduction, the fundamental principles, observed motion, computational model, results, discussion, and the conclusion. Introduction. The purpose of this experiment is to observe and measure the motion of a mass swinging in an arc while oscillating on a spring. Using these observations, we created a model that follows this motion and measured the energy change as well. Our results were that the potential and kinetic energy were opposite to each other, which implies that the total energy was equal to zero. Fundamental principles. So we use Newton's second law, Hooke's law, and conservation of energy to help us during this experiment. Observational motion. Here's the video through tracker, and we were able to extract the initial position of the system, the initial velocity, the stretch length of the spring, and the mass was 0.402 kilograms. We calculated the spring constant K from the observed motion on the x-axis because it was the more nicer curve, and we found that Ks was equal to 5.9114 Newton per meters. From Newton's second law, we calculated the initial spring length, which is 0.336 meters. We then inserted our initial condition into our code and the calculated value of Ks and L0. We then used the formula for the Newton's second law and the conservation of energy formulas to calculate the change in energy in our code. As you can see here, here's the motion of the mass into glow script, and we can see the change in energy versus time and the change in the position versus time. Results. The blue curve is the predicted motion and the red one is the observed motion. The observed motion almost fit the predicted motion at the beginning, but as time goes over, there is more discrepancy, which could be due to drag or dissipative forces. Discussion. We can see in the change in energy that throughout the whole time, the potential energy and the kinetic energy are in opposite sign, which implies that the energy is always equal to zero. So in our case, the energy principle is satisfied because it's always equal to zero throughout the time. Estimating the spring constant using X position and Y position data. So here you have the two X and Y position, the two period that we got from the graph, and the two Ks values. The one on the X direction is more accurate, which could be explained that there's less disruptive forces on the X motion. Conclusion. From this experiment, we can conclude that the energy principle is valid, that our model is accurate but needs to be improved and take in consideration drag forces.